Just a minute. Now, first of all, the principal value. Principal value. Okay. For that, like what's the value of sine inverse 1 over 2? What's the value of cos inverse root 3 over 2? Okay, that's the principal value. What's the value of theta? Like theta equals tan inverse 1. So what's the value of theta? That will be the principal value. But for that, we have to understand first the range and the domain and range. Domain and range. Okay. Uh, the domain for sin x will be real numbers. That real numbers means from minus infinity to infinity. That's real number. So the domain for sin x will be real number. The range will be from -1 to 1, and both of them will be included. So likewise for cos x, domain will be real number, range will be -1 to 1. For tan x, domain is real number and range is real number. Okay. Now for sorry, this was sin tan x. Now for sin inverse x, the domain is -1 to 1 and the range is from minus pi by 2 to pi by 2. For cos inverse x, the domain is Shruti, do you know what's domain and range?
Yes.
Okay. So that will be from 0 to pi. That's the range of cos inverse x. Okay. For tan inverse x, the domain is real number and the range is from minus pi by 2 to pi by 2. Okay. We'll use this to get the principal and general values.
Okay.
What's the principal value? Okay, we'll start from sine. Sine inverse 1. Okay, we have to find the value of x or theta. Theta will be sine inverse 1. So to find the principal value, what we'll do is this principal value always lies inside the range of the function. It will always lie inside the range of sine inverse. So theta will be equal to sine inverse sine pi by 2 equals sine inverse sine inverse 1. Okay. So in place of 1 we have written sine pi by 2. So theta will be pi by 2. Theta will be pi by 2. And this is the principal value of the function. Okay. This is the principal value of the function.
Okay.
Okay. Now Now we'll move to the general, or we'll just see one more principal value. Like see theta is equal to sine inverse minus 1 over 2. So that will be theta equals sine inverse sine minus pi over 3 equals sine inverse sine inverse minus 1 over 2. So in place of minus 1 over 2, we wrote sine minus pi by 3. So the value of theta will be minus pi by 3. Okay. For principal values, sine inverse sine x is equal to x, and sine of sine inverse x is equal to x only if x is in domain of sine inverse x. Only if x is in the domain of sine inverse x. Okay, now we'll find the general values. Uh, like what are general values? See, sine 0 is equal to 0. We know that sine pi is also equal to 0. Sine 2 pi is also equal to 0. Sine 3 pi is also equal to 0. These are some values of sine which are equal to 0. Now, if someone asks you that sine inverse x is equal to 0, then what's the value of x? Let's say someone is asking you the value of x. So we have two answers. One is the principal solution. The first is the principal solution. So among all the values of x, uh, there can be uh, 0. Sorry, I wrote this. That will be sine x equal sine inverse 0. That's the question. Okay. So the value of x can be 0, pi, 2 pi, 3 pi. So the principal solution will be 0 because only that value is inside the domain of sine inverse x. Only that value is inside the domain. Rest all the values will be included in the general solution. So those will be 0, pi, 2 pi, 3 pi. Those are the general solution. Now how will we find the general solution? We have to draw the graph of sine. Then we'll derive a formula. We will draw the graph of sine. You have studied trigonometry, so I think you are familiar with the graph.
Yeah.
Okay. Now the question is, what's the value of x if sine x is equal to 1 over 2 or x equals sine inverse 1 over 2. So what we do here is this line which I have drawn in the top, its equation will be y equals 1. Its equation will be y equals 1 because the maximum value of sine is 1. So likewise what we'll do is we'll draw a line which is y equals 1 by 2. The given value of sine y equals 1 by 2. Okay. Now we drew that line. We'll see where that intersects with the graph of sine x. I'll be solving, you recognize the pattern and try to tell me if we can use a formula or not. So the value of sin x was 1 over 2. So we drew two graphs that were sin x and 1 over 2. Now this value will be, okay, this value will be 0. This value will be pi over 2. This value will be pi. This is 2 pi. This is, that will be 3 pi. It will be, sorry. This will be 5 pi by 2 and this will be 3 pi. Okay. We'll get our answer from this much. Okay. So the first value of x that we are getting is, you can also see this part. This part is pi by 6. Can you write the small, can you see the small things I'm writing in that?
Yeah.
Okay. So to find the values of sine, what we'll do is the first value, the value of x. The first value of x will be x, that will be 0 plus pi by 6. So that's where the graph intersects each other at the first point. Then after that it will intersect at pi minus pi by 6. We have to come back pi by 6 from pi. So that will be subtracted from it. After that, the value is 2 pi plus pi by 6. Because pi by 6 has been added in that, then it will be 3 pi minus pi by 6 and it will go on. Now we can see a pattern here that there is a multiple of pi. There is a multiple of pi and pi by 6 either it is being added or it's being subtracted in that. So the value of x is n pi. That's the multiple of x. That's the multiple of pi. Plus, now there's an alternate positive, negative, positive, negative. So we will write that as minus 1 to the power n minus 1 to the power n pi by 6. Okay, but the answer isn't finished here. What we have to do is we'll see whether this is correct or not. So we can use the value of n as 0. So or 1. When we use n equals 1, so x will be pi minus pi by 6. So we got this value. So our answer is correct. We will check it. Okay, so this is how we found the inverse of 1 by 2. So the inverse of 1 by 2 is n pi minus 1 to the power n pi by 6. Okay,
Okay.
so from here we got the value. Okay, from here we got the value x. We got a formula, that's x equals n pi plus minus 1 to the power n into theta. Okay, now x and theta, what are these? So x is the, sorry, we'll start from theta. Theta will be the general solution and x will be the principal solution. Okay, theta will be the, I wrote that wrong, sorry. Theta will be principal solution and x will be general solution. Theta will be, this theta will be always be inside the range. It will be always inside the range. X could be inside the range, could not be inside the range. Now we will solve same for cos. You can note down these formulas or take a screenshot.
Okay.
Now we will start for cos theta or cos inverse, anything. Now in the question it's asking that we have to find cos inverse 1 over root 2. That's the value of x. So cos x will be equal to 1 over root 2. 1 over root 2. Now we'll do the similar thing here. Okay, we drew the graph. I will draw the graph of 1 over root 2. So it will be shorter than 1. So it will be anywhere here. Okay. Now we can see that it intersects at some points. This value where it intersects the graph, it will be pi by 4. That will be pi by 4. And this part, it will be minus pi by 4. Now we'll write the values of x. We'll start to write the values of x. So the first value what we got was 0 minus pi by 4. That's the first value of x. For the second value we have 0 plus pi by 4. Okay. For the next value, uh, it's 0 pi and here it will be 2 pi. So 2 pi minus pi by 4, 2 pi plus pi by 4. Okay, these are the values. Now we can see that the values of x is 2 and pi. That's an even multiple of pi. So 0, 2 pi, then the next will be 4 pi. That's an even multiple of pi plus minus pi over 4. So on one of the solutions it's plus and one of the solutions it's minus. So we can also write
Okay.
a formula for that. It will be x equals 2n pi plus minus theta. So here theta will be the principal solution and x will be the general solution. So this was for cos. This formula was for cos x. Now we'll derive the same for tan, and then we'll move on to the questions. For tan inverse, for that we'll take tan x equals tan inverse, let's say root 3. Tan inverse root 3. So tan x will be equal to root 3. We'll apply the same method. These are the coordinate axes. Now this is the graph of tan. Okay, it will work. You don't have to draw too many graphs. We'll figure the answer out from this much. Okay, now we drew tan x. We will draw y equals root 3. So this is y equals root 3. And we can see that y equals root 3 cuts the graph y equals tan x sorry, at these points. At these points it's cutting, so it's 0, pi. This value is equal to pi over 3. It's pi over 3 because tan pi over 3 equals root 3. So from here, the values of x are 0 plus pi over 3, then pi plus pi over 3, and we can see that the next will be 2 pi plus pi over 3. So x is equal to n pi plus pi over 3. N pi plus pi over 3. That's the value of x. So that's our formula. Our formula will be x equals n pi plus theta. And theta is the principal solution. X is the general solution. Okay. So we got the three formulas. First of all, we'll find the principal solution. First of all, we'll find the principal solution in every question. Then we'll find the general solution. Okay. Our first question is sine inverse 1. So the principal solution will be pi over 2 because sine pi is equal to 1. That's our principal solution. For the general solution, we have for the general solution the value will be 2n pi 2n pi okay, sorry, that was n pi plus minus 1 to the power n into theta. So for here it will be n pi plus minus 1 into pi by 2. And we can also write in that in the terms like see 0 pi plus minus 1 to the power 0 pi over 2 pi pi plus minus 1 to the power n pi by 2. So that will be minus pi by 2, sorry, that will be pi by 2, that will be, for the second one it will be pi by 2, for the third one it will be 3 pi by 2, and likewise it will go on. Now sine inverse 1 over root 2. So the principal value will be, principal solution will be, okay, what's the principal solution, Shruti? Here,
Sine pi over 2.
okay. See, x is equal to sine inverse 1 over root 2. So sine x will be equal to 1 over root 2. So the value of x is pi over 4. That will be pi over 4. See, sine pi over 4 is equal to 1 by root 2. So that's our value of principal solution. Now we'll find the general solution. For the general solution, that's n pi plus minus 1 to the power n pi over 4. So the general solution will be n pi. Okay, we got the general solution. We'll be putting the values of n and we'll be getting the general solutions. Shruti, once we are done with these questions, do you have any homework or anything you want me to solve?
Yes, I do.
Okay, so we'll quickly sum up this. Cos
Okay.
inverse root 3 over 2. So the principal solution will be, in cos it's in cos inverse question we have to see, we have to be careful when there's cos inverse involved. So the principal solution will be pi over 6, because cos pi over 6 is root 3 by 2, and the general solution will be 2n pi plus minus pi by 6. That was the formula for the general solution. Likewise, we have to find cos inverse minus 1 over 2. Now we have to be cautious. Uh, how will we find the principal solution here? See, let's suppose this is theta. So cos theta is equal to minus 1 over 2, and this is equal to minus cos pi over 3. Okay. So the value of theta is not equal to pi over 3. We cannot write that. We also cannot write that theta is equal to pi minus pi over 3. That's also wrong. So what we'll do here is we'll use this formula. Cos 180 minus theta is equal to cos theta, and sorry, that's equal to minus cos theta. So we'll apply pi by 3 there. In place of 180 we will be writing pi. So cos pi minus pi over 3 is equal to minus cos pi over 3. So this will be cos 2 pi over 3 equals minus 1 over 2. So that's how we will be getting the the principal solution for cos.
Okay.
Okay. Now we got the principal solution. For the general solution, that's 2 That's 2n pi plus or minus 2 pi over 3. So that's the value for the general solution. Now for tan inverse 1, the principal solution is pi over 4 because tan pi over 4 is 1. Okay, now for the general solution, we have n pi plus pi over 4, n pi plus theta. That was the formula for general solution. Now tan inverse root tan inverse minus root 3. So that will be the principal solution will be minus pi over 3 minus pi over 3 because tan minus pi over 3 is equal to minus root 3, and the general solution will be n pi plus minus pi by 3. So that will be n pi minus pi over 3. Okay, Shruti, do you have any doubts?
Um, no.
Okay, so I'll stop the whiteboard and you can share your screen now.
Okay.
Shruti, are you sharing the screen?
Um, the PDF is still loading,
Okay,
so I
okay,
haven't started yet.
okay.
Is it showing now?
Yeah, yes, I can see that.
Okay.
Okay, so we'll be solving the 12th question.
Yeah, I think I understood the questions before it, but when
Okay,
I got to this, we didn't cover any word problems, so I'm not sure how to do it.
okay. So there's this projectile motion, and we have to find the. Shruti, are you allowed to use the calculator in class or in the test?
Yes, I
Yes,
think um,
I think sometimes you are allowed and sometimes you're not allowed.
yeah.
Okay, just a minute. I'm not getting the editing access for that. Uh, Shruti, I'm not able to edit this. Is there anything you can do about that?
Um, I think I clicked something that said to
Okay,
enable annotation.
yes, I got that now. The editing access. Okay, so this
Okay.
is our projectile motion, and you can see that it's symmetrical about the midline. It's symmetrical about the midline. So what happens is with what theta will be here, that angle will be there. So this is called the angle of projection. It's related to physics. Now we throw the ball like this, we throw anything like that, and that can start from the basics. Okay, just a minute. Okay, so this is the projectile motion, and it's symmetrical about this point. This is called the angle of projection. By the angle of projection is the initial angle made by the projectile's velocity with the ground, and the same angle is with the same angle is the angle with which it hits the ground. So both of these angles are same. Okay. Now this is the range. This is the horizontal range from the start point to the end point. This is called horizontal range. The projectile is the object which is thrown. So its journey starts from ground and it ends on the ground.
Yeah.
Okay. Now, if you can throw a basketball with initial speed, what angle of elevation should you direct the throw? Okay. So in the question, we are provided with in the question we are provided with initial speed, that's v naught, which is equal to 34.8 meters per second. We have r, that's the distance of landing. So it says 107 meters. And then we have g. So g is equal to 9.8 meters per second square. So now we'll put the values. Now we'll put the values, and sine 2 theta will be equal to r g over v0 square. So sine 2 theta is equal to okay, Shruti, shall I explain the problem once more or shall I continue?
I I'm understanding so far.
Okay, so the value of r here was 107 the value of G was 9.8 and the value of V naught or V0 was 34.8 and it will be squared. Okay, now I'll be using the calculator and I'll be telling you the value.
Okay.
Mm, Now it will be, so I got the value of theta, that's theta is equal to 24.4 degrees. So this was the value of theta which I got. So this is the angle of elevation by which the ball was thrown. 24 over 24.4 degrees. In the calculator, I got the value of this value. I've put sine inverse in that. So 2 theta was about 48.8 degrees. So theta was 24.4. Okay. Now
Okay.
in the next part of the question, it's asking that determine the maximum distance that you can throw the ball. Okay. So the distances are the maximum distance is r. Okay. So r is equal to Shruti. Can you tell me? Uh, okay. So we are throwing a ball, and we have to throw that with the maximum distance, maximum horizontal distance. So the value of g will not change as it is the acceleration due to gravity. The value of v naught will not change as it is the because v naught is the value of velocity, the maximum velocity. We can change only theta. We will be changing the angle of elevations, so the range of the ball will differ in each of the case. Now, for the maximum range, sine theta will be also equal to its maximum value. So sine theta will be equal to 1 here. Sine theta will be equal to 1 when we have to maximize the range. So sine 2 theta is equal to 1. So 2 theta is equal to pi over 2. That's the principal solution. And theta will be equal to pi over 4. Okay. Or that will be 45 degrees. So always remember when angle of elevation or angle of projection is 45, the horizontal range will be maximum. What's the horizontal range? It's the distance covered in the ground from the point of projection to the point of landing. From point of projection to point of landing. Okay. Okay. Now
Okay.
we'll see the next question.
I completed these, I
Okay.
think. Um, yeah, these.
Okay. So we'll have to solve this. Okay. Uh, Now we'll find the value of sine inverse. Sine inverse 3 over 5. So we know that sine 37 degrees is equal to 3 over 5. This value you have to remember. Do you remember this value?
Um,
Okay, so
I
I'll draw a triangle and you have to remember that triangle. You can take a screenshot or draw it. This is the right angle and this will be 53 degrees. So this is the triangle you have to remember. So you can
okay.
see from here that sine 37 is 3 over 5. Okay, so you can take a screenshot. I'm going to erase that
Okay.
after some time. So sine inverse 3 over 5 will be 37 degrees. So cos 37 degrees plus minus, sorry. We are dealing in degrees here. We can also write in radians. So minus cos inverse 1 over 2. So for the value of cos pi over 3 is 1 by 2. So cos inverse 1 by 2 over will be, that will be pi over 3, that will be 60 degrees. So that's cos 37. Okay. Now cos 37 minus 60 will be cos minus 23, and that will be cos 23, because cos minus theta is equal to cos theta. Now we got our answer cos 23, and you can check that with the calculator. What's the value of cos 23? That will be the answer.
Okay.
Okay. Okay. Now for the second one, or the 12th question, it's sine minus 1 over 2. So that will be 10 sine inverse 1 minus 1 over 2, that will be minus pi over 6 minus tan inverse. You can see that tan 37 is equal to 3 over 4. So tan inverse 3 over 4 will be 37. So when we are writing that in degrees, we will also write this in degrees. So that will be minus 30 degrees minus 37 degrees. So that will be tan inverse minus 67 degrees, or minus 10 in, oh, okay, so that was 10, not 10 inverse. Okay, so it's 10 minus 10 67. This is our answer. We can check the answer, or we can find the answer with the calculator, the final answer.
Okay.
Now for the third part, we have sine of 2 cos inverse. Okay, so we have to find first cos inverse. We know that cos 180 minus theta is equal to minus cos theta is equal to minus cos theta. So here it's 3 over 5. We have to find the value of cos inverse minus 3 over 5, and we are finding that using this formula. So cos 180 minus 37 will be equal to minus cos 37. So cos that will be 143 degrees. Okay, that will be 143 is equal to minus 3 over 5. So we got our answer. Cos inverse minus 3 over 5 is 143 degrees. So cos inverse 3 over 5 is equal to 143 degrees. Okay, now we'll find that. Sine of 2 cos inverse, that will be 143 degrees. So sorry, that's only sine. So it's sine 286 degrees, and whatever the value of that will be, answer. Whatever value we'll get from it in the calculator, sine 286. Okay. Okay,
Okay.
what's the next question? We still have some time left in the class. Oh, okay, so 16th and 17th. The 16th question is such that sine 2 pi is equal to minus 1. So we will find the principal solution here, and see here in place of the angle it's 2 theta. So 2 theta will be equal to sine inverse minus 1. That will be 2 theta equals minus sine inverse 1, and sine inverse 1 we can write as pi over 2. So 2 theta will be equal to, okay, 2 theta will be equal to minus pi over 2. Then theta will be equal to minus pi over 4. So that's the value. But it's asking that, okay, okay, that will do the work. Now for the second one, tan 2 theta is equal to 0. Okay, I think there will be more answers to it, because mm, it's asking, okay, we got the wrong answer. Sorry. It's wrong because it says that theta must be between 0 and 2 pi, but we got the value of theta as minus pi by 4. So from the equation of general solution, we will take another value of theta. So the next value of theta will be, the value of theta is 2n pi plus minus 1 to the power n into pi over 2. This was the general solution for this question. Now when we kept n equals 0, we got minus pi over 2. Sorry. this part is minus pi over 2. When we kept n equals 1, we will be getting mm, 2 pi plus pi over 2. So that will be 5 pi over 2. 5 pi, sorry, that was n pi actually. So n pi will be getting 3 pi.
Okay.
I wrote the wrong formula. So for n equals 2, we will be getting 5 pi over 2. So we will take another value, that is 3 pi over 2, and we'll check if our answer is correct or not. So 2 theta will be equal to sine inverse minus 1. 2 theta will be equal to minus sine inverse 1. Okay, so 2 theta will be equal to 3 minus, plus 3 pi over 2. So theta will be equal to 3 pi over 4. So this is our correct answer. We can use that from the general solution if we are not getting the answer within the range. So we'll also check further. So this is our correct answer. When we
Okay.
when we check further, 2 theta can also be equal to 5 pi over 2. So theta will be equal to 5 pi over 4, and this is also within our desirable range. Likewise, the next value will be, this is also correct. The next value will be 2 theta will be equal to 7 pi over 2. 7 pi over 2. So theta will be equal to 7 pi over 4. So this is also our correct value because it is inside the range 0 to pi by 2 theta. For the next part, it will be 2 theta is equal to 9 pi over 2. So theta will be equal to 9 pi over 4, and it's greater than 2 pi. So that's not our answer. We have three solutions for this equation, and the three solutions are 3 pi by 4, 5 pi by 4, and 7 pi by 4. Because we got these values from the general solution, and these are inside the range. So these are our three solutions. Now for the second question, that's tan 2 theta equals 0. Tan 2 theta equals 0. We will write the equation for the general solution first. So the principal solution is 0 because tan 0 is 0. And we have to remember that we are writing the value of 2 theta here. So
Okay.
2 theta is equal to 0, and okay, this is the principal solution. General solution will be 2 theta is equal to n pi plus principal solution, that will be 0. So 2 theta will be equal to n pi, and theta will be equal to n pi over 2. So the values of theta will be 0, pi over 2, 2 pi over 2, 3 pi over 2, and it will go on.
Okay.
Now we'll use the first value. So 10. Okay, I think we got the answer because these are the values of theta and we have to find theta. 0 will be a correct answer because it's inside the range and it also satisfies the equation. Pi by 2, 2 pi by 2 will be the correct answer. 3 pi by 2, 4 pi by 2 will be also the correct answer. No, that will not be the correct answer because it's equal to 2 pi and that's not our condition. So the answer is
Okay.
0, pi over 2, pi and 3 pi over 2. So these are our answers which also satisfy the equation and are also in the desirable range. Okay, Shruti, can we end the class for today?
Yes.
Okay, thank you.